Okay, guys, last three for your starter today. Again, from the benchmark. What we noticed is as a class, I mean, everyone, um, all three science teachers, we noticed that questions 8, 9, and 10 seem to be the ones that you guys struggled with the most. Okay. So for question 8, I don't know if it's because there's a little bit of reading here and you just get lost in it. So I'm going to model for you how I would approach this type of problem. All right, students have two balls with two different masses to use in an experiment. Which experimental design will allow the students to determine how the mass of an object affects its motion? All right, so the first thing, as I scan down through here, I immediately see that they want me to know what the independent and dependent variable is. The independent variable is the thing that I can make different at the beginning of the experiment. What is different? So let's look again. I want to determine how the mass of an object affects its motion. And it says that I've got two balls with different masses to use in the experiment. So that immediately tells me that the independent variable in this experiment is going to be the mass of the balls. All right. So the independent variable, the thing that will be different, is going to be the mass of the balls. And then apparently I'm going to measure the dependent variable is what you measure or record at the end of the experiment. So I'm going to record or measure something that has to do with motion. I don't know yet. I haven't read the answer choices, but I know that mass of the balls is my independent variable. So answer choice A says assign mass as the independent variable, assign velocity, and I know that's speed with a direction, as the dependent variable. So it could be A. B says assign mass as the dependent variable. All right, well, I can get rid of answer choice B immediately. Boom, it's gone. Answer choice C, assign mass as the independent variable. That's right. Assign velocity as the dependent variable. Okay, C is a possibility. D, assign mass as the dependent variable. That's not right. Boom. So I can get rid of B and D. So now I just have to look at A and C. So I'm going to go back here and look at A. Let's see. Assign mass as the independent variable. Okay. And I could draw a picture if I wanted. I would have, I don't know, a ball with a mass of, 200 grams and another ball with a mass of 500 grams. And it says assign velocity is the dependent variable. So apparently I'm going to measure something and determine velocity. Give the ball with a larger mass a larger forward push than the ball with a smaller mass. Measure the time it takes for each ball to travel 10 inches. Calculate the velocity of each ball from the data. Well, I know I can calculate velocity. That's just speed with a direction. And speed is distance, 10 inches, divided by time. So that's okay. My concern right here is I know that I have to there's only one thing that I can make different, and that's the independent variable. Everything else has to stay the same. And this says give the ball with a larger mass a larger forward push. Well, that doesn't seem right. If I push that large one more, that seems like that's going to mess things up. Let me go down here to C. Assign mass is the independent variable. That's right. Assign velocity is the dependent variable. That's okay. Give each ball a forward push of equal force. That sounds right because everything has to be the same except that one independent variable. Measure the time it takes for each ball to travel 10 inches. Okay. And then I would use that time and the fact that the ball travels 10 inches to calculate velocity. All right, so the correct answer is C. All right, for number 9, a student designs an experiment using a magnet, a paper clip, and a thin piece of wood. The student measures the maximum distance that the paper clip can be placed away from the magnet on a table and still be affected by the magnetic field. The student repeats the procedure after placing the piece of wood between the magnet and paper clip, and the diagram shows the maximum distance for each design. Okay, so that ruler is kind of hard for me to read, but I can see that looks like right now the paper clip is, I think that's 6 maybe inches or centimeters, I don't know, inches away, and it can be attracted to the magnet. Now it looks like when you put that thin piece of wood there, that this paper clip can still feel the magnetic field because it's maybe not quite as strong, but it can still feel it because I noticed that it still doesn't have to touch it, and it can still, be affected by it. Okay. What conclusion is supported by the results? Okay, the magnetic field is blocked by the piece of wood. Well, it's not completely blocked. If it was completely blocked, it wouldn't affect the paperclip at all. So I don't think it's A, but I'll keep that one in mind. That's a little tricky. The magnetic field is reversed by the piece of wood. No, I don't see any kind of magnetic field north and south poles reversing. The magnetic field passes through the piece of wood. Well, I mean, it must, because some of it is still coming over here affecting the paper clip. And the magnetic field increases through the piece of wood. Well, it definitely doesn't increase because I notice it can't, the paper clip has to be closer in order to feel the effect of the magnetic field. Well, I'll tell you, I can definitely get rid of B. B is out. And I can definitely get rid of D. Now, this is tricky. I'll grant you that. But I believe the correct answer is C, because A says the magnetic field is blocked. If it was completely blocked, then this paper clip would not be affected at all. But the magnetic field is capable of passing through because this is still affected. So the correct answer is C. And what's the last one? A person brushes the hair on a cat with a metal comb. The strands of hair begin to stick up in the air and move away from each other. What type of force causes the hair to respond in this way, and why? Well, hopefully we know by now that's static electricity. And so I assume what's going on there is that we have some electrons that are leaving the cat hair and being attracted to the metal comb. That means the cat hair, since they lost electrons, the cat hair is now all positively charged, and they're going to repel each other and move away from each other. Let's see. And right here's my answer. It's an electric force. The strands of hair become positively charged when negative particles from the hair move to the comb during brushing, and the correct answer is B.